We've been talking about hijacking at the application level, at the browser level. But how about hijacking a little lower down in the OSI model? We could hijack at the network level, regardless of if this is a telnet session or a browser session or whatever session. It's possible. So there are a number of ways to hijack at the network level. And I don't mean the layer 3 network layer. It could be at several of the layers here. It really depends upon the protocol, and what we're doing is we're abusing the good nature of the protocol. A variety of things we could do. We could do a blind hijack. We could do a UDP or a TCP hijack. We could do a reset hijack, which is a TCP hijack. We could do a man in the middle with a packet sniffer. We could spoof our IP address and request source routing. So starting with just TCP session hijacking. You know, and you know this from Network Plus. When a client talks to a server, there's a three-way handshake, right? The client says SYN, the server says SYN-ACK, and the client says ACK. Thank you very much. Let's get started. The main feature of doing this handshake is to establish the starting sequence number. Because the way TCP is connection-oriented, the way it's considered reliable, is it keeps track of every little piece that it sends. So it will send a couple pieces and wait for an acknowledgement, send a couple pieces, wait for an acknowledgement. And that tracking mechanism is the sequence number. So in the beginning of a TCP session, we always start with sequence number 0. I mean, it's possible to start with a different number, but that's not typical. So that's the handshake. When I say SYN, I am saying my starting sequence number is 0. And when the other side acts back, it tells me what it expects. And since I already got 0, I expect number 1 off of you. So it's SYN 0, ACK 1. And then part of that server response is not only an ACK to me, but also the server's starting number, which will be SYN 0. So it's SYN 0, ACK 1, and SYN 0. And then I am obliged to ACK 1 back. That's the handshake. So if you are a malicious hijacker, you could be watching the communication back and forth. Because after the handshake, the next thing the client needs to do is send some kind of request to the server. And it'll do it in TCP segments. So here comes request number 1, 2, 3. And the client waits. The server will say ACK 4. Then the client goes 4, 5, 6. And the server says ACK 7 because it acts the next thing it expects. You can watch this rhythm. 1, 2, 3, ACK 4. 4, 5, 6, ACK 7. 7, 8, 9, ACK 10. 10, 11, 12. And you're watching. There's a rhythm to it. And just at the right moment, as you're predicting what the next numbers will be because you've been watching it, you deauthenticate the client, you push the client out of the way, and you take over. So it's like 1, 2, 3, ACK, 4, 5, 6, ACK, 7, 8, 9, ACK, push them out of the way, and you jump in and go 10. And the server thinks, oh, the client is still there asking for number or presenting number 10 to me. It's kind of like watching girls play jump rope. You see two girls with big old rope like this, and you see some girls on the side just getting the rhythm before they jump in. It's a similar thing. But imagine a girl's in the middle jumping, and another girl's on the outside. As she jumps in, she pushes the middle girl out of the way. That's kind of like what a TCP layer session hijack is. We don't do it so much anymore. And one of the TCP defense mechanisms that was added on later was to have the sequence numbers jump seemingly randomly. But it's not truly random. I mean, in computing, nothing is truly random. It's all pseudo-random because there's an algorithm that tries to make it look random. So watching long enough, you can figure out the algorithm. And I mean, you can figure out the numbers, and you can still predict, and then you can jump in there. You have to do something to deauthenticate the client, the original client. Typically, you do it by sending in a FIN or a reset packet where the client thinks, what? The server reset my connection, in other words, I don't have one? That's the most common thing you do. So that is the TCP hijacking mechanism. So we take over a user's place or a client's place after it has established a connection with a server. They have already logged in. Now, of course, this has got to be in clear text. It's got to be like Telnet or something we can watch. We need to observe and correctly predict the TCP sequencing numbers. The packets cannot be digitally signed or stamped in any way that identifies the sender. So we watch the client and server sequence numbers going up, up, up. We send a spoofed TCP fin packet to the client, finish, or a reset packet, either one, and the client goes, oh, I lost my session, okay. We then jump in, either spoofing our IP or our MAC address so the server doesn't see any difference. The client disconnects, we're now in its place. And we keep sending disconnection notices to the client so it never tries to connect back. Another thing we can do is source routing. This is something that should be disallowed on your network, but in the original TCP/IP, it was permitted. A trusted host IP address can be allowed in simply because the IP address is on a list that's trusted. So I will change my IP address to be spoofed. You can do this with MAC addresses too. Depends upon the application. I can change my IP address so the server will think, oh, this is a trusted person, they're on the list, and it will accept the packet. Now, of course, with using a spoofed IP, unless I have a mechanism for them to connect back to me, I won't get any responses back. But that might be okay, because maybe all I need is to just get the packet there. I don't care about response. So what I can do is, as soon as a legitimate user establishes a session, but prior to the host actually sending anything, I'm going to forge my packets and get them in there. So the server gets the packet from me. The original packet from the host after they've logged in is lost. And then the attacker, pretending to be the regular client, keeps sending packets to the specified destination. We can also do reset hijacking, and this goes back to that TCP session hijacking. We send reset packets that look authentic, that usually tell the client that, hey, your session is done. And then if we can also know the acknowledgement number, we can reset the user's connection saying, acknowledge and sorry, we're finished. So the user, well, the client machine, not the actual person, thinks that the reset packet was sent by the server and resets the connection. And there are any number of packet crafting tools we can use. Blind hijacking is typically done with source routing, meaning that I am inserting myself in the middle here. Let me just zoom in so you can see a little bit better. So here's a victim who would have a normal connection to a server. I'm going to intercept the request, and then I'm going to inject malicious data here. The server responds back to the original user. We never see the response, but hopefully we see the end result. So that would be blind hijacking. We can forge ARP, we can forge ICMP, we can forge TCP. We can use a sniffer that inserts itself between a client and a server. We can ARP spoof, sending phony ARP requests or ARP replies to fool those machines and make them think that their IPs are our MAC addresses, and we talk about ARP spoofing elsewhere. And so then what we're doing is we're trying to change their ARP cache, their ARP table, so that when they are trying to talk to each other, they're sending it to our MAC address, and then we are relaying between the two of them. UDP hijacking, this is a lot easier because there's no session, but it's hard to do in some ways. So the attacker sends, you have a client. They make a normal UDP request to the server. What we have to do is we have to quickly send a reply that's bogus before the server has a chance to. It's easier in the fact that we don't have to take over anybody's three-way handshake. It's harder in that we have to sneak in there before the legitimate server responds normally. So that's UDP hijacking. So those are some common network level session hijacking techniques.